Hello, this video is for the Semester 2 review packet for our Semester 2 final. This is the Solving Quadratics section. Looks like it is questions 12 through 19 in your review packet. So another reminder, you can feel free to watch the whole video if you just want to check your work, or just watch it to watch it, or you can skip around and look for the questions that you specifically wanted to see. Alright, so quick review, we should talk about strategies used for solving quadratics. So first off, solving quadratics means that we're figuring out what is x when y is 0. So I'm going to really quick, bear with me, sketch a parabola. So there's my parabola. So we're looking for what is x when y is 0. So really what we're finding are the x-intercepts. Some other names we used are the roots or the zeros. So we're figuring out what are those things in these different equations. We had 5 strategies we learned when we were studying this unit. First was to graph your quadratic. If it's already graphed, it's super fast to figure out your solutions. Factoring is another strategy. Square root was the third. Completing the square was the fourth. And the quadratic formula was the fifth. You will get the quadratic formula on the semester 2 final, so you don't have to have it memorized. Okay, let's get started. Find the solutions to each equation when y is set equal to 0. So right away they're saying set y equal to 0. Okay, so then I have 0 is equal to x minus 3 and x plus 7. That's what we're doing when we solve a quadratic. We're saying what is x when y is 0. So we're trying to get 0 for y. That can happen by either making this parenthesis equal to 0 or this parenthesis equal to 0. So, in this case, if I make this first parenthesis 0, x would have to be 3. Another option would be to make this second parenthesis equal to 0, because either way, if one of them is 0, the whole thing becomes 0. So my solutions would be x is equal to 3 or negative 7. Middle one says y is equal to x squared minus 16. So again, we're making y, oops, let's back up a little bit. Y should be 0. So I'm going to cross that out and put 0 there. So we're really trying to solve 0 is equal to x squared minus 16. This could be solved 2 different ways. You could factor it, so you'd end up with 2 binomials like in that example. Or you could use square roots here, since the x squared doesn't have an a value greater than 1 and there's no b term. So if I wanted to solve using square roots, just so I can show you guys another strategy, I would want to add 16 to both sides. So that's gone. So then I have 16 is equal to x squared, and then I would square root both sides. Don't forget, when you take the square root, I end up with a positive and a negative 4. Because 4 times 4 is 16, and negative 4 times negative 4 is 16. Last one, y is equal to x squared minus 7x minus 30. I can't use square roots here, so I'm going to factor. That's usually my go-to, or one of my first initial strategies I try. So I would use diamond and box. If you need a review on factoring, go back to my other video or come in for help, but I would set up in diamond and box because this is a trinomial. When I factor it, I got 0 is equal to x minus 10 and x plus 3. So I just replaced that y with 0 because we're trying to solve it. So that means x could either be positive 10 or negative 3. Alright, question 13. If the sides of a rectangle measure x plus 4 and x minus 1, and the area of the rectangle is 36 square centimeters, what is the value of x? So we know we have some rectangle. Tells us that. It also tells us the sides are x plus 4 and x minus 1. Oops, that should be minus. And we know area is 36 centimeters squared. We need to figure out the value of x. So first of all, a couple of key things. We have a rectangle and we know its area. I'm going to assume that I may need to incorporate the equation for area of a rectangle, which would just be length times width. So if I plug in what I know, I have 36 is my area is equal to my length times my width, so x plus 4 times x minus 1. Still just trying to solve for x here. So you have a couple options. I am going to use the quadratic formula here. You could also use completing the square if you wanted to. Either way, we first need to multiply out our two binomials on the right side so you can distribute a bunch of times. So if I do that, I get 36 is equal to x squared, and then I have x times -1 minus 1x. 4 times x is 4x. 4 times -1 is -4. Combine that -1x and 4x, so 36 is equal to x squared plus 3x minus 4. Now if I'm going to use the quadratic formula, I have to have 0 on one side of the equation, so I need to subtract 36. So I have 0 is now equal to x squared plus 3x minus 40. So now I'm good to use the quadratic formula. I'm just going to set it up. I don't have room to go through every single step, but when I set it up, it looked like, if you remember, the formula is opposite of b plus or minus the square root of b squared minus 4ac over 2a. Kind of long. Pause the video, write that down. So opposite of b, so -3 plus or minus square root of b squared, so 3 squared minus 4, and then ac, a is 1, c is -40, all over 2 times a. So what I ended up with, if I simplify a little bit, was -3 plus or minus the square root, and that became 9 under the square root plus 160, so 169 over 2, and then I kept simplifying from there. When I did that, I got x was equal to 5 or -8. So here I know if I'm talking area that the negative doesn't make sense. So I'm going to go with x is equal to 5. That would be my final answer here because they only asked for the value of x. If they asked for the length or the width, then I would go back and plug x, which is 5, into the binomials to get that. Okay, 14 says the graph of y equals 10x squared plus 19x plus 6 is shown to the right. Explain how you can use the graph to find the solutions. So remember, solutions is the same thing as zeros or roots or x-intercepts. So I'm trying to look for those x-intercepts, which would be about right there and right there. It's hard for me to put the dot exactly, but I'm looking for where it crosses the x-axis. So here, x would be about, I think I said -0.4 and -1.5. And those would be my solutions. So I'm just looking for the x-intercepts. Now if, for example, I had a graph that was up here and it doesn't cross my x-axis, that would be an example of one that has no solutions, which is possible. Okay, 15 says the graph to the right shows the height of a ball with respect to the time since it was thrown. Estimate the coordinates of each of the following points and explain its significance in this situation. So vertex is highest point in the graph, about right there. The coordinates of that would be 2, 22. And I know if I'm talking about a ball being thrown in the air, that would be the time that the ball reaches its max height. So at 2 seconds, the ball reaches a max height of 22 feet or meters, whatever it's being measured in. Oh, meters, there it is on the graph. Okay, x-intercept is where I cross the x-axis, that's here. X is about, I'm going to draw that down here, so for B, it's about 4.1, y would be 0 there. So if x, which is time, is 4.1, that means it took 4.1 seconds for the ball to hit the ground, for the ball to be at height of 0 meters. And then I have the y-intercept, which is right over there. It's a little squiggly. But that would be when time is 0 and the height is 2. So at that point, that's just the starting height of my ball. So time is 0. It hasn't been thrown yet. It's right before I throw it. That ball is starting from a height of 2 meters. Alright, 16 says use the quadratic formula, x equals the opposite of b plus or minus b squared minus 4ac over 2a to solve each equation. My biggest piece of advice here with the quadratic formula is just take it one step at a time. It's easy to make a mistake or to drop a negative if you're not careful and you try to do a bunch of this in your head. So use the formula to your advantage. use the calculator to help you and just take your time. So biggest thing we have to remember is everything has to be on one side. So you have to have 0 on one side and then everything else on the other side. So A is good because we have 0 on one side by itself. If I look at A, I can see that A is 1. B would be 3. That's sloppy. And C is 1. I'm going to plug that into my formula. So I have opposite of B, so -3 plus or minus. Okay, not sure if my video skipped around from the last slide. If it did, I apologize. Solving each equation. So now looking at all the examples here in 17, these all lend themselves nicely to using square roots or solving using square roots. So remember that the regular formula is ax squared plus bx plus c for a quadratic. If you're missing that middle term, that bx, that's usually an indicator that using square roots will work out nicely. So looking at A, well, x squared is already by itself, so I just have to take the square root, so I get x is equal to plus or minus 6. Don't forget, there's 2 solutions. Looking at our middle term, in my head I'm reminding myself that I need to get the x squared by itself. So I would start out by adding 15. I get 3x squared is equal to 15, and then I would divide by 3. So I get x squared is equal to 5, and then I would take the square root of each side. So I get x is equal to plus or minus the square root of 5. If I didn't see this on my test, then I would enter the square root of 5 in my calculator and change it to a decimal, see if I can find it that way. If that still doesn't show up, then I'd go back and check my work. Alright, for C, a lot of kids want to multiply out that binomial when they see this squared, but the parentheses, so that x plus 2 squared is by itself on one side, and 49 is by itself on the other side. So I can actually square root this right away, and I would get x plus 2, oops, that's sloppy, sorry, is equal to plus or minus 7. This is an instance where I would split my equations, and I would do x plus 2 is equal to 7, and x plus 2 is equal to -7, and solve each separately. So I'd subtract 2, so x would be equal to 5, and x would be equal to -9. That would be the fastest way to solve this one. Alright, 18 says fill in the blank so that each trinomial, and it should be, is a perfect trinomial squared or a perfect square trinomial. Remember, when we think of a perfect square trinomial, it's one that can be written as one binomial squared. That's what we're going for there. So we practiced these with some of the algebra tiles on the Chromebooks together to see if we could find a pattern. And there's a few things we have to remember. So we're trying to take, oops, that's real big, sorry. We're trying to take that, what will be a trinomial, and make it into something x plus or minus something squared. So what I'm going to do is I'm going to take half of the b value, so half of 4, which is a positive 2, and that's going to go in my parentheses, and then I square what I put in my parentheses to get my missing number here, which would be 4. And if I were to multiply out x plus 2 and x plus 2, I would get x squared plus 2x plus 4, which is x squared plus 4x plus 4. So I can see my work is correct. For the middle one, I'm going to have x plus or minus something. I take half of that, which is -12, gives me -6, and then I square that -6 to get what goes in the blank, so it gives me a 36 there. There's my perfect square trinomial. And then for our last one, ooh, it's a fun one, -5. So I'm going to have x, and then something squared. I'm going to take half of that, so I'm going to leave it as just -5/2. If you prefer working with decimals, change it to 2.5, that's fine. Then I know I have to square that, so I'm just going to do -5/2 times -5/2 and multiply them as fractions. That'll give me 25/4. Again, you could change that to a decimal and that still works. Alright, slide 10, last one here, solve each equation by completing the square. So let's think back to what we were just doing. Remember those blanks are there because we have to figure out what we add to each side to force the left side to become a perfect square trinomial. So x plus or minus something squared is equal to something. We take half of 2, which is a positive 1. Square that positive 1, I'm going to add 1 to both sides. So that gives me x plus 1 squared is equal to 6. Now I can square root each side. So I get x plus 1 is equal to plus or minus the square root of 6. Oops, that should be square root. If you want to change it to a decimal, it would be x plus 1 is equal to plus or minus. Let's see here. I think I rounded to 2.45. And I would do x plus 1 is equal to 2.45. And x plus 1 is equal to negative 2.45. Subtract 1. I get x is 1.45. Subtract 1 here. And x is negative 3.45 are my two solutions. Now at any point on the final, if you're not sure if you did something right, remember that you can plug x in and make sure it works out. Alright, again for B and C, I'm kind of tight on space here. B is already in the right form. When you use completing the square, you want it to be ax squared plus bx is equal to c. So you have that number by itself. So B is already in the right format. So again, I'm just going to give you the final answer, but if you got stuck somewhere, please ask me so you can check your work. As kind of a middle step, you should get to x plus 5 is equal to plus or minus the square root of 29. And then I changed that square root of 29 to a decimal, and I solved that 2 times, and I got x is equal to 0.39 and negative 10.39 as my two solutions. And for the last one, you'd have to subtract the 10 first because we want ax squared is equal to, or ax squared plus bx equal to c. So x squared minus 6x is equal to negative 10. So this one I would have x squared minus 6x. Thinking, what do I add to both sides? So I would get, let's see, x, ooh, it's getting sloppy. Let's back up for a second. Taking half of negative 6, that gives me negative 3 squared. So I have to square negative 3 to get 9, and I'm adding to both sides. So I get x minus 3 squared is equal to negative 1, square root each side. Here's where I run into an issue. I can't take the square root of a negative, so this would be no solution. Thanks for watching, guys. Again, I think my video may be cut out at some point here. I apologize for that. If you have questions, please email me, come see me in the morning. Just make sure you ask, and keep studying hard.